Welcome to this session. This session will discuss how to change from base 10 to base 8. So the process remains more or less the same as what we did in conversion from base 10 to base 2. But then the thing here is that the divisor, or we are dividing, the divisor will be 8, or in each process we are dividing through by 8. So you say we use the division algorithm repeatedly and terminate when you obtain a quotient of 0 apply or use division algorithm and stop or terminate when we obtain a quotient of 0. Then write the remainders in the reverse order, i.e. bottom up. So this way we have the bottom of economy. Or we can say we divide, or if you don't want to use division algorithm, you say divide by 8, which is the new base, repeatedly noting the remainders at each stage. And then the next step, continue dividing until a 0 quotient is obtained. And then finally, write all the remainders in the reverse order from bottom to top. So this way the Hustler Nation got their phrase of bottom up. So let's do an example. So change 524, which is a number to base 10, to octal. So that's the problem. So we are going to demonstrate both ways, dividing repeatedly by 8 or using division algorithm. So method 1, repeated division by 8. So repeated division by 8. So we write So we have the 8 itself. I have the number 524, and then you write the remainders. So 8 divides 524, 65 number of times, and then the remainder is 4. And then 8 divides 65, 8 number of times, and the remainder is 1. 8 divides 8 one time, and the remainder is 0. And then 8 divides 1 0 times, and the remainder is 1. Now immediately you get a 0 remainder, you stop. So because now 0 quotient, because now we have 0 quotient, you stop when you have a 0 quotient, not remainder. So because now we have a 0 quotient here, then we stop. And so 524 to base 10 is the same as, write this one in the reverse process, 1 0 1 4, then to base 8. Or you can write 524 to base 10 is equals to 10 14 to base 8. Or method 2, division algorithm. Division algorithm. So our A, so remember division algorithm is A equals to B Q plus R. And then you do it repeatedly. So we have A equals to B Q plus R. So B, the base in this case is 8, and then A will start with 2 or 524 given. So 524, 8 divides 524, 65 number of times. The remainder is 4. Then you bring 65 here. The divisor remains to be 8. 8 divides 65, 8 number of times. The remainder is 1. Then bring this 8 here. 8 divides 8 1 times, and the remainder is 0. Then bring this 1 here. 8 divides 1 0 times, and the remainder is 1. So because now at this stage we have a 0 quotient, this 0 quotient, then we stop and then write these remainders in the reverse process. So therefore 524 to base 10 is the same as 1 0 1 4 to base 8. Or you can write it as 524, put in brackets, subscript 10 equals to 10 14, and then base 8. Remember, these numbers are order sensitive, so this is how you need to write them. We're saying from bottom up, not the other way around. If you write the other way around, then the meaning of that number will be different. Another example 2. Example 2, find the octal expansion of this number 1 2 3 4 5, which is in base 10. So we do this by division algorithm, but you can as well do it using repeated division by 8. So we write 1 2 3 4 5. The divisor is 8. So 8 divide this number 5 15 43 number of times, and the remainder is 1. Then you bring 15 43. Divisor is 8. 8 divide this number 192 times, and then the remainder is 7. Now bring 192 to the left. Divisor remains to be 8. 8 divides 192 24 number of times. The remainder is 0. And then 24, 8 divides 24 3 times. The remainder is 0. Bring 3. 8 divides 3 0 times, the remainder is 3. Now, because this step or this stage is where we get 0 quotient, then we stop and then write the remainders in the reverse or the bottom up order. So therefore, 1, 2, 3, 4, 5, which is a number to base 10, is equals to 3, 0, 0, 7, 1 to base 8. Or you can write it as just 1, 2, 3, 4, 5. Then you write subscript 10 equals to 3, 0, 0, 7, 1 base 8. So that is how we do that problem. Thank you.